I'm gonna shut off my Discord, so if anyone's typing on there, I'm not gonna see it. Okay. Let's see, share screen. Okay, perfect. So where do I begin? I'm gonna talk about, this is where I learned my data science, okay, Fast AI. Kind of hypocritical because their goal here, I kind of showed this last time for anyone that went to the workshop last year. This is a group that its goal is to make neural nets uncool again. What does that mean? They actually want this to happen. They don't like how data science, at least the deep learning side of things, has been gatekept by grad school. Okay, people think if you want to do deep learning and go work on self-driving cars, get a master's or PhD, and that's kind of changing now. So undergrads or even high schoolers are able to do deep learning because of libraries like this and wholesome communities on PyTorch and stuff. And yeah, also if there's any questions as I'm talking, if I somehow miss it, just unmute and ask, or Manjot, you can read it out whenever. Zoom in, please. Sorry, Rex. Thank you. Okay, I found the chat. My bad. Okay, so yeah, this is Fast AI, and they have a book. It's nice. They have their library with lots of tutorials. Everything is written in Jupyter Notebooks. I'll go over what that is. And they have a lecture series. I'll paste a link in the chat, and I'll make a post on the Discord with every link, every page I'm going to show you today. Okay. So when I became an intern at the lab, my mentor told me, check out Fast AI. I went here, clicked this first page, went to the lessons, and this is where I started my journey. And these guys are amazing. Okay, I actually met one of the professors in real life, Jeremy Howard, and he's like one of the greatest deep learning people, and he didn't even go to college for this, which is awesome. And it's cool because the way they teach it, a lot of machine learning and AI classes, especially in grad school, is like they teach you the theory. They teach you a lot of math, a lot of theory. You don't get to work on stuff, right? But these guys, they do it backwards. They throw a notebook at you and they show you how to train your models and actually do deep learning. Then they take a step back and explain how it works really easily. And they make the analogy of like baseball. When you play baseball for the first time, you just hit the ball. You don't learn physics first, kind of like that. And they kind of highlight these two platforms to kind of get started as a workspace. I'll go over those in a second. But here's some myths that you might have heard that I love going over. Lots of math and deep learning. Nope, just algebra. Lots of data. Yes, if you're doing something that has never been done before. But 1 second. But generally speaking, there's something called transfer learning, where you get these models that are trained on huge amounts of data. And I mean, like, consider a model that can differentiate 1,000 different classes of objects: cat, dog, person, chair, glass. And it has seen 1 million pictures. And if you think about that for a second, if there is a model that can do that, which there is, that's some crazy understanding about imagery. Not just about those objects, but by just the shapes, the lines, the colors, the textures. And you can imagine that to solve a task like that, it will probably be also useful for something it hasn't even learned yet. So if you can learn 1,000 classes and then you want to say, hey, you know what? I want to differentiate. If I take a picture of a phone, can I classify if it's an iPhone or a Samsung Galaxy? And you can use the knowledge of the model that has learned 1,000 classes because it transfers well. Phones, like the objects, they have rectangular shapes, which are seen in tables. They have lines, they have texture. And it actually lets you use like a couple hundred pictures to just train something like that with like 90% accuracy probably. If you didn't use transfer learning, then yeah, okay, you got to get like some hired data annotators and get a couple of thousand images, but that's in the past. So it's really easy to do deep learning and just take something that's been done and just apply it downstream to your idea. I already seen 2 people here at the hackathon that are planning on doing something like that, which is kind of neat. And the other thing is you need expensive computers. And people say, oh, you need GPUs because you got to put it on the GPU to make it run faster. Otherwise, it'll take days. Yes, but there's Collab and Paperspace, which give you GPUs for free for like 6 hours. And that's all you need to train something pretty quick, unless you're doing some heavy research with like OpenAI or something. Yeah, so here's the kind of different areas. There's NLP, which is your input here is text, and your output could be things like summarize a document, classify a sentence as like toxic or not toxic, find a name inside the text, or do question answering given a context. Computer vision, classify the image is a classic one. Object detection, heavily used in self-driving cars. Generation of images like GANs. I'm sure you've seen deep fakes. Those are made with generative adversarial networks, GANs. I actually have something on my GitHub that shows how to put a picture of yourself in there, get your lane code, and you can actually switch parameters to make yourself smile, frown, change genders, age, younger or older. And that's all with generative networks. That's what I did for my hackathon at the lab. You can actually morph from one person to another frame by frame and see how it changes. It's really cool. Image generation recommender systems, think Amazon, Netflix. Playing games in robotics use something called reinforcement learning. Don't ask me about that. I still need to get my foot in the door in that field, but most of the neural network stuff, which I'll show, is what I'm familiar with. Okay, so that is my introduction to ML, DL, motivations for it, things that are possible, and hopefully you're a little bit cleared. From what's my GitHub? Okay. So really quick, I can just show this. This is an Epoch and blog. Occasionally I write like a blog post. So I go to notebooks and I go to latent space exploration with StyleGAN2. StyleGAN2 is a model that's known for generating realistic looking images of people. But there's a way to project yourself into the code that it will use to generate what it thinks of you. So if you can find that code, you can actually play with it and just like see how things change. So for example, this is a fake person. This is a fake person. Here's interpolation. So from this picture, you can kind of slowly go by just changing the code. And a code is just a feature vector from a network, which I'll kind of show. But just to show, like this is Jeremy Howard, like the leader of Fast AI. This is Obama. These are the original pictures. And I found the code to generate as close as possible what they would look like. So side by side, it gets most of the details right. So from 512 numbers, I can make this picture or this picture in high quality. And you can make them smile, right? You can make Jeremy old, you can make him younger as a kid, or turn him into a girl. Sorry, there's not two genders, more than one, but in this case two. Closing the mouth or make Obama age. And this is all with like generation side of deep learning. That's just one field. It's really, really cool. So yeah, Fast AI, my number one recommendation to start. I know I spent 10 minutes on this page, but that's how important it is to me, at least, in just getting people started in the field. All right, so to do deep learning, what is the most common development station? Okay, as CS majors, undergrads, you guys probably use your notepad files, Vim, Nano, Visual Code, Atom, Eclipse for Java. You just write code and you run the executable, or if it's Python, you just run it. VS Code, master race for anything but deep learning for me. But so what people use is something called Jupyter. Okay, and this comes with Anaconda, and Anaconda is basically Python but with a bunch of libraries. And this is Jupyter. You can type in code, like here's a variable. This is Python, by the way. It's all Python. You can set variables and you can do things like +2. And you can run things in pieces. Right, and then I can call this function. So the idea you should get from this is that it's super interactive, okay? And the reason why this is important is because in deep learning or machine learning, you don't just run the code and you have an algorithm. You want to take the data, you want to inspect the data, you want to make sure that you understand what you're working with. You want to be able to print out the model and see what the model is going to be doing. Then you want to combine the two to train it. And then afterwards, you want to evaluate it and then finally do it for inference. And just to do all that in one file is crazy, or multiple files. Sure, but it's super helpful being able to run things at a time so you can see what things are happening in each variable or data. set. So to get Jupyter Notebook, you can run it locally. And it's the best because everything's in your computer, sure. If you don't want to run it locally because you want a GPU to make things run faster, there's two options. Okay, Google Colab is here. And this is, it is a notebook. It doesn't look like it. Yeah, same idea. Oh, also I forgot to mention, in notebooks, you can have markdown cells. So you can kind of type markdown, that's what this is, or HTML. And then when you run it, it just looks nicer. But the idea is the same. You have code blocks. Colab is awesome. I'm gonna roast it just a little bit. It's good, except that like you have to, sometimes it'll turn off randomly. I'm not sure if they fixed that. And you have to mount your Google Drive in order for things to save. And you don't really have like a terminal. I mean, you do have a terminal here. I guess they kind of do. I'm not sure if you have a terminal here, but basically it's known for just running a notebook. So if your goal is to, yeah, it crashes a lot, sure. It's not a Jupyter server. You don't have access to the actual server. You see here, this is actually a directory. And I can go to new, and I can go to terminal, and voila, I'm on a Linux machine. I can do ls, I can cd into clean, I can do top, I can do NVIDIA SMI, which is a command to see how much GPU space you're using. That's a really important one. So I have a GPU called Quadro M4000, and it has 8 gigs, which is pretty big. I can put a model in there. So that's nice and all. You can run commands in Colab by putting exclamation mark in front of it. But it's great for when you have a notebook. You can just drop it in here and just run the cells real quick setup. But this is pretty good. Now, this isn't too well known. It's like my secret tool that I use to just like jumpstart anything. And it's called gradient paper space. Okay, let me type out the links here for people that just want to write it down now. That's Colab. Gradient paper space is here. So here you sign up for free. And when you sign in, you'll be brought to a console screen, okay? And here, I don't do too much on here with projects, data sets, clusters. That's like way past my usage. So what you want to do is on the notebook screen, you hit create, give it a name, so like HackMerced, and then you want to choose a container. Okay, so you're probably wondering what the heck are all these? Because I'm going to say NVIDIA Rapids is the least important one for me. And I guess this is a good time to talk about what do we use to do deep learning? Okay, there's two sides, and eventually you guys will be pledging your allegiance to one or the other. There's the PyTorch team, and there's the TensorFlow team. Those are the main two. Okay, PyTorch is made by Facebook, and it came out after TensorFlow did. TensorFlow is really hard to use. The community doesn't have that many good tutorials. Messy code, debugging is a nightmare. Don't even get me started on installing CUDA drivers. I would not recommend it. I just at all times. Everyone at the lab knows I can just roast TensorFlow for hours. PyTorch, fresh, clean, easy to run. The community is great. Forums are super active, and there's so many tutorials, at least back then. Now, okay, sure, TensorFlow 2, they did a carbon clone of PyTorch, and they made it so much easier to run, good. Community is nice, good. They have community tutorials, good. And it's not that bad. So, I'm not hating on TensorFlow anymore, but TensorFlow 1, if you're following a tutorial and you see TensorFlow 1, find a different tutorial, unless it's some really old code that you can't get anywhere else, because that does happen. I do that for work sometimes. So I'm going to choose PyTorch. That's like the standard deep learning. You can make neural nets very easy here, okay? This is also the most complicated, even though it's easy to use and learn, it's the most complicated tool, okay? Transformers in NLP, this is called Hugging Face, right? So let's go to PyTorch first. This is where all the deep learning happens right here, PyTorch. And they have lots of great tutorials. Again, I'll paste this here, show you how to install it. Most importantly, the tutorials is great, the docs are great. So if I go to here and I go to transfer learning for computer vision, remember my example of using a big model that has seen 1 million pictures with 1,000 different classes. How can we use that information? Here's a notebook, and they even have a button where you can hit run in Colab. So you can see they're doing imports, they're loading the data, they're visualizing the data, they're training a model. And well, this is a function to train a model. And then later on, they kind of define a convnet. And it's really easy. You just say, let's just use a Resonant 18. That's a very popular model. And pre-trained 2 means let's use the information it has learned from those 1,000 classes. And they get it. And then they just train the model on this new data. And then they can kind of see the predictions. And it's just a super clean tutorial, top to bottom, end to end, for getting the data, getting the model, training it, evaluating it, visualizing the data in a notebook, top to bottom, couple cells. Really neat. And this is PyTorch. You know, if you need to look at the docs, you can go here. You can go to torch.nn. This is the main thing. And you can see all the layers. You know, here's a conv2D layer. To actually build your own network, they have tutorials in there too. I'll be happy to mentor or help people that need to do it, but I kind of want to show some other stuff. Okay, so that's PyTorch. Transformers and NLP. This is a group called Hugging Face, and they are the leaders of NLP. And by leaders, I mean anything you hear about NLP, language generation stuff, these guys are doing it. They use something called a transformer. It's the best network to use for machine learning with text. Before, people kind of like converted the text into little tokens, and they kind of like did n-grams and could look at 3 at a time, like a sliding window. Then people got fancy with LSTMs and RNNs, which are recurrent neural networks, and they look at one word over and over, and they kind of have a history to remember what they've seen in the past. Nice, but you can't parallelize it because each word depends on its previous word since it has memory. Transformers, they take the entire text in at once, and they look at all the words at the same time, and it actually learns how to pay a certain amount of attention from one word to all the other words. So I was giving this example earlier. If you have a sentence saying, the woman crossed the road, then got hit by the car. Okay, terrible example. I don't know why that came to mind, but the woman, that word, and then hit by the car are on 2 different spots of the sentence. Transformer will automatically just say these 2 attend very well to each other, and it actually just helps it perform a lot better. And they have, just like images seeing 1,000 classes, these models here have been trained on Wikipedia web scrapers for millions and millions of text. Dude, this is a tricky thing. For the images, you're thinking, oh yeah, it's easy. You have a million pictures. Each one has an object. Just say what it is. You know, I'm telling you it's a dog, so just learn it's a dog. But if you have 100+ million paragraphs of text from Wikipedia, what are you going to ask it to do? What's your label? Because you just have the text. So the coolest thing is about these transformers, the goal here isn't to predict, oh, that is classification, because you can't do classification on all of Wikipedia. It's too much. So what they did is they take in a sentence and they find a word and they just mask it. So the woman crossed, blank it out, and then hit by a car. What's the blank? And the model has to use all the other words to guess what the word is. In this case, it would be the road, right? So to do a task like that, you don't need labels, you just need data and just mask out tokens. So they did this for like 100+ million paragraphs. And what resulted from this is like the strongest language model that this field has ever seen. It's amazing. You can give it a sentence and it has this incredible understanding of it. And it's the best way to do NLP. LSTMs are still good in certain cases, but a lot of people say it's kind of overrated. Sure. But it's also really cool. And what people do is they take this amazing language model, and then now let's say you have a task of Kaggle. You go to Kaggle, it's a competition website. Companies post their problems, the data, and they see you can get the best accuracy or something on a leaderboard, and they win money. Okay. More commonly, great for data sets. So let's look up NLP data set, right? And we have coronavirus tweets, NLP, Jigsaw, BERT, pre-trained models. I like this one called toxic classifier. So this one's pretty cool. It's basically about what kind of toxicity you're classifying. Is it identity, hate, insult, obscene? What level of degree is the toxicity of the message? And to do that from scratch is kind of hard because you're asking it to not only learn the English language, but to understand how it has negative connotation to it at once. Okay, that's a really hard task. But using this Hugging Face library with this transformer they built, all you gotta do is you take their model that has understand English just as well as we can, and we just say, hey, I'm gonna give you this sentence, get your special representation, magical understanding from it, give it back to me. It's just gonna be like 500 numbers, but those 500 numbers mean so much, and you can use them to train a tiny little linear classifier model that just takes those 512 numbers and maps it to identity, toxicity, or racism or something, and it'll learn it. You can train it that way with a much less amount of data. So this is the best way to get the best results, kind of. It's like everyone uses it. It's a great tool, but it's not the quickest, because you do have to kind of learn to process your NLP data, because you can't give your model text. You have to convert your text into tokens. So if you have, like, for example, hello world, I'm doing a workshop, you can't just give that to a model. It actually gets converted to something like this. Each number represents a different word. And sometimes words get broken down in subparts so you can understand it. That's just a high level intro to NLP. We can go into detail if anyone needs to later. But yeah, you have to kind of process your data a little bit. And if you want to train your model, there's some scripts to help you for your specific task. If you want something done the quickest way, so the longest way is PyTorch, because you do everything from scratch. You write your own data set, you define your own model, you train your own model with your own function, and then evaluate it, and then so on. Hugging Face is nice because you just have the data sets. They even have a library for data sets, by the way, just to see all of them. You just go here, you click on data sets, and boom, everything. Adversarial QA, given a question answer that's been manipulated, can you still have a robust answer? All sorts of stuff here. It's really, really good. And they have also the autofill method. Oh, it's like masked. It has to do with mask. The technical term is, if you type in like birth loss function, they have like they'll explain what they're doing there. There's different losses. So your loss is your goal. So for example, a goal for NLP would be, given a text, can you classify as toxic, yes or no? That's a loss. For BERTs, given a text and I cover a word, can you guess the best word that's kind of closest to it? And that works really well too. And I think they also do sentence entailment, so predict, whether the two sentences kind of flow together and stuff. Or something along those lines. I need to really revisit some of the stuff here. But there's all sorts of loss functions for all sorts of these transformers. That's what these big NLP models are called. But the mask one is like one of the most popular methods for sure. Other ones, they add more loss terms. But sentence entailment and masked loss are the two for this transformer. And this is basically the state of the art that everyone uses. For the training, the autofill. Remove, what's a bit from the sample data? Like splitting the data? Sorry, I don't remember what I said, I'm sorry. You mean autofill for like making sure you have a specific length on the text? Padding, perhaps? I guess the token? Yeah, essentially you just convert your sentence into integers, which are like tokens, basically. And that's the input to the model. Yeah, we can go into like way more detail and look at an example of that very soon. Back to gradient paper space. So that's transformers NLP. This will, if you choose this container, it'll just have everything you need to use it. You choose this one, it'll have PyTorch ready to go. Since Hugging Face is built on top of PyTorch, this will come with PyTorch too. So remember, PyTorch is used for everything. That's how you just run neural nets and make data sets and stuff. So this library is built right on top of it. Consider it as a high-level library for PyTorch. And FastAI, same thing. But FastAI, they don't just do text like transformers. They use neural networks. You can use a transformer in here, but neural networks and transformers are of the same kind, by the way. It's just transformer is just like its own topic. When people say neural net, they just mean like ConvNet or recurrent net or just like a normal one. But FastAI is great. So PyTorch is the hardest. Hugging Face is like the next hardest, kind of easy, not too bad. But FastAI is like the ultimate tool. People win Kaggle competitions with this thing. I'm not even kidding. And it has so many applications. All right, so if you click on FastAI and you go here and you choose, say, free GPU, you get this for up to 6 hours. You have more options. If you choose more, you have to pay. So just pick 6 and then hit start. And then when you hit start, you're going to get to, say, this page. And at the bottom, it'll say launching at the very bottom left. Very small. I know it's kind of hard to see. I apologize. And then when it runs, you'll see this little button here, a little orange button. It says open in Jupyter. If you click that, you get to go here, your own Jupyter server as if it was running on your own machine. And it's like awesome because it's totally private. And the best part is you can actually send this URL out to your team or anyone else, and you can kind of just run on the same server and look at your notebooks and stuff. It's really, really cool. You do need to give them the token. To get the token, you go here. This is the passcode for this notebook. So right now, if you guys just type in this URL and you hit enter, and it says, what's the passcode? You would put this in, and you would literally have control on this same machine I'm using right now. The reason why I don't need to put the code in is because I'm logged in to Gradient Paperspace. You don't have to do it for yourself. So yeah, let's look at some notebooks. So this is like the quickest tool to get something up and running quickly. Given that you guys have 36 hours for a hackathon, it might be pretty useful. If not, and you're not using this, I mean, hopefully it'll be useful in the future for like a Kaggle competition or a class or just a fun project you want to do. I'm going to go sidetrack a little bit. For a fun project, when I was a grad student, I'm not sure if any of you guys played Clash Royale, like on the phone. Like it's like a card game made by the people who made Clash of Clans. A couple years old now. Yeah, I know. I hit like 6K trophies, man. When I was a TA, I was like, guys, join my clan. Funniest thing. But basically, I made AI to do computer vision on the spectator screen. So I'm not sure if you remember, but when you play someone, people can spectate your game, right? And they can see like the hands of both players. More importantly, the cards kind of flash when they're played. If you use logic, and like when I say logic, I mean just like rule-based logic, saying if someone put a card down, that means it's at the bottom of their deck, right? True. If someone put a card down, that means they had the elixir to play it. You can hold a 10 elixir. Each card takes some amount to put down. I made 2 convolutional networks using Keras. Okay, Keras is basically the fast AI of TensorFlow. I know, don't roast me. I didn't know. I was young back then. Nobody told me how cool PyTorch was. So I used that, and I made a ConvNet that can just basically know when a card's played and which one is played. And then using time, elapsed time in Python, you can kind of guess how much elixir they're generating. Put a cap at 10, you know which card they're playing, and you can kind of keep a track of their deck. So the end product was I was able to make a card counter for Clash Royale, and I can see how much elixir they have and the exact cards they have in their hand and which ones are coming off. So I posted it on Reddit, and it got like top page Reddit on Clash Royale. And then the mods were like, you can't do this, dude. This is like gray area cheating, right? I'm like, but what about Google? Look at what they did, man. They have a 5v5 AI Dota team that beat the best players in the world. You don't see them getting like yelled at. It promotes their game. What the heck? And they said, true that. And they let me keep my post in. And it was really cool because like that was like one of my first GitHub projects I did for fun. And I got a bunch of stars and something to talk about. Wow, it's at 37 now. Holy, okay. But yeah, this is what it looked like. And I just did this like during the summer, right? And you can see like, you know, opponent's elixir and upcoming cards and stuff. And it was just like a fun little thing. I didn't expect it to get popular. And then when I applied for the lab, I was talking to one of the mentors, and they're like, so what have you done with like, computer vision or like deep learning? And I said, oh, oh wow, you sort said thanks for not showing me deep learning. That's one thing, but in grad school I learned a little bit. So grad school did help. I learned gradient descent, so I was able to talk about gradient descent for some time, and then I was also able to talk about this project that I did for fun and not for a class. And to say that you made something like this for fun and you're just kind of promoting it like online just to like do it for fun, it stands out. And I generally feel like that's one of the reasons why I got brought into the lab, is because I just did something like this like for fun. And it was like really quick. I made my own data set, got my model. It's my first time doing something with confidence, and it wasn't too bad. And I'm able to talk about it to people, and it just like stands out. So the whole moral of the story is, even if you're not doing something like this for the hackathon, deep learning is an easy way to think of cool projects to do. You just get data and you can train anything you want. You go downstairs and you're making mac and cheese, take a couple of pictures of your mac and cheese while it's cooking, take a couple of pictures after it's done cooking, and boom, you have a data set that can tell you whether or not your mac and cheese is cooked or uncooked. And just train a fast AI classifier on it and then put it into an app. You never know, and then just advertise it. And it looks silly, but it's something to talk about and shows you have the skills to just do something computer vision related really quickly. I didn't use fast AI for this, but if I ever revisit this, I definitely would revamp the code to hide the TensorFlow. So yeah, that's just an example project that you can kind of do really quick. And that was before I got into the field too. And yeah, so let's look at FastAI and some kind of applications for it. And again, if you ever want to learn about FastAI, this lesson, like hour, 30-minute videos, 2 hours, this is where I started, just these lessons, and then the second half. And it's amazing. So when you launch your paper space in Jupyter, if you're using the FastAI container, which you should, you get this screen, and you have these notebooks here. I was playing with them earlier, so they're not original, but if you go to a clean, these are the original notebooks, and you can just copy them back over if you want to restart. So let's look at a couple of these, all right? And we're going to talk high-level deep learning, look at examples of different kind of products. Ooh, no, that's not the term. Applications. So let's check this out, right? So number 5, pet breeds. So let's look at here. Oh, okay. So this is not the originals. That stuff. We're going to look at these ones then. So they have pet breeds. They have multi-category classifications. They have tabular data. So if you have data in the form of a table, like a CSV, you can do some training with neural nets here. You have NLP. They do NLP. I was saying transformers are like the best thing ever, but what FastAI made is kind of like LSTM, I think, or some other network, but it's a really, really good one too, and it compares very well to transformers. And all you got to do is just give it your CSV with text and labels, and you're good to go. And then the latter ones are the technical pieces: architecture details, special optimization methods, convolutions, how do they work. The first half is just showing you how to do it. The second half is if you want to understand what's happening under the hood of this library, they'll explain what convolution is in PyTorch and show you visualizations and stuff. I kind of started with that last time. I just went over ConvNet and all the details and what's happening inside a kernel and stuff. While it's good to know, it felt more like a lecture of a deep learning class rather than just giving people what they needed to get stuff done. So we're trying something different this time. So image classification. All right, so if we just kind of skip down, there's a lot of text here. This line, they're just gonna untar the data. So URLs pets, we just take this and we make a new cell and we paste it and run it. It's this link. So this is what I mean by interactivity is like the most important thing, because you can just print stuff out whenever. Okay, so I put it in, I'm getting a tar file. So it's just a tar file. And if we just play with the URL, if I just go back one folder, we get this. So I was hoping to maybe see like a list of files we can kind of pick. So it looks like it's an S3 container. We can't really do much with that. But they actually have on their documentation of FastAI all the different types of data sets you can use and download with their library. So you don't have to go do it yourself. So let's just look at pets. So if you untar it, which is what they're doing, I guess they give you some kind of folder somewhere. Yeah, there's like a default directory they download your data in, and I think it's in here. So we make a terminal, we type in ls-a, ignore, clean, tools. Let's see, home directory maybe, fast AI, so we can go in here. No, yeah, I meant, can you use direct on the pets variable? Yeah, I mean, so on tar, we can just look, if you hit Shift Tab in Jupyter, you get auto documentation. Best thing ever, just like this. You can see what the functions take. If you want to go a step further, you can do untar data and just put 2 question marks and hit and run it. And you get this here. So this link is just the gradient paper space link earlier. Yeah, this is like the best thing. You don't have to go around jumping your files. You can just double question mark and boom, you get documentation. So if you look at this, you get the URL, and they're kind of like downloading it. Force download, yeah, that's good. Path, they can download the new version. It's cool. So destination, they have a very specific location here. Yeah, I guess like I wanted to see where it was here, but they'll show it later. It's fine. Is it in the cloud? Yeah, this is a notebook that's running somewhere else in the world, and it actually saves everything you do. So next time you run it, it's all saved. Yeah, it's very useful. So path dot slash images. There's this one. So there's just a bunch of images in this folder, wherever it's at. I thought it would be in here, but I guess it might be somewhere else. I can find it later. It's fine. That's the one thing about FastAI is they put their folders in hidden folders instead of just like normal ones sometimes. But yeah, so let's keep going. So they're getting the first one. So if you do .ls, it's a custom path function. It just returns all these. You're gonna get the first one, print it out. So there you have a ragdoll image, and they have some regex to kind of find ragdoll. So what they did here is they took the image path and they ran regex to parse out this. Why would you want to do that? This is the class. So they're kind of showing you how to process your data. You can go from something like this that's labeled kind of weirdly, and you can kind of do some parsing and get the class. And this is an example of a data block. There's a lot of examples on this on their docs, but basically you're going to give it an image and a category, and then get image files, which is going to find all the files in the directory specified. It's going to split. So when you're training, you don't want to use all the data you have. You want to do like 80% for training, and then hide the other 20% so the model never sees it and memorizes the data and cheats. And then you use the other 20% to kind of see how well it's doing, since it doesn't know what it is. To get the label, why is label? They're putting this here because that's what they wrote to get ragdoll. It doesn't have to be this complicated. If you have like a CSV of labels, there's a function that just takes the CSV and looks at the first column. Resize, they're going to resize all the pictures to 460 by 460, and then augment the size to 224, so I guess smaller, and then something with scales. Image augmentation is like a whole other area. So they're kind of showing like how they're doing their augmentation. If you think about it, if you have a picture, there's so many things you can do. You can crop it, you can rotate it, you can change the hue values, you can warp it. And if you do all those things with that one picture, you can actually create multiple different samples of the same object that look different without having to go get more data. So it's really hot for data augmentation. Even blurring is one of them. So yeah, let's just go down. This is kind of like where I kind of like stopped it. But over here, this is how easy it is to create a model with FastAI. DLs is a data block thing. You just give it your data object. You give it a model you want to use, and then what you want to print out. And you just type in dot fine tune, and that is it. Okay, it has the whole training loop. It'll get the data from your data loader. It'll pass it to the model. It'll calculate the loss. It'll do the backprop gradient descent to update all the weights in the network, and then repeat for every data. as many times as you want. That's what epic is, how many passes over your data. Training loss is how you want to see this go down. For training loss, it should be going down because it's looking at the training data. So it should be getting better and better. Validation, it doesn't see the validation data, but if it's going down, that means the model is learning to generalize. It's learning to understand the training data without having to memorize it because it's able to do well in data it hasn't seen. Error rate is basically how much they're getting wrong. How would you make your own data loader? So we go to fast.ai, we type in docs, dots, go to data loader. Core actually is a little bit better. So they have like data blocks is the easiest way. So they have, it looks complicated, like a lot, but usually it's always image block, category block, and then you want to specify a function that will get your files for you. And grandparent splitter means if you have like a folder saying data, and then train folder, validation folder, and then your images, it can look one folder up to see it's in the train or val. There's all these different kinds of methods to use with examples. The best way to do this would be to just look at one of the notebooks or your specific application. So if we go to Vision here, it's as easy as this. You see image data loaders, we can go here. We can just say, give me data loaders from a path. And in this path, there'll be a train folder and a valid folder. And all you got to do is make 2 folders, drop all your training folders in there, and, training data in there and all your validation data in there. And it'll kind of know. So back to this one, the MNIST. This is what the data looks like. You can see it's in the MNIST tiny folder, valid, and then 7. This is 7 because these are inside this folder are all the images that belong to the class 7, a digit 7. And there's also 3. So you can kind of use that as like a way to kind of like separate it. And there's like so many different examples on kind of like how to do this. The best way again is to go through like one of the notebooks and kind of like change one little piece for your own data, or kind of mimic the way they have their data, but with just your samples on it. That's what I did my first time. But yeah, so you can like run this and it'll train. And let's kind of scroll down a little bit. This is a little bit more technical because they're kind of show stuff here. This is a nice little figure. It's called the confusion matrix. You have all these different classes of pet breeds, right? Bengal, Berman, and so on. And the diagonal is basically showing you how much it got correct. And things off the diagonal are the ones that got wrong. So if we look at American Pit Bull Terrier, it has a 10 here because they got it confused with Staffordshire Bull Terrier. So those two are really confusing. I think in the lecture video, he actually looked both of them up and they look like indistinguishable. So that's why I did really bad, because it's even hard for humans to do it. And you can kind of like see it here. And there's ways to kind of like improve it by fine tuning with like advanced statics, like freezing the model weight so you only train the last layer and stuff. Or a learning rate finder. So one of the things you need to do when training is you got to pick a learning rate, and it tells you how much to learn. If it's too high, your model is going to explode. The gradients blow up. It's too low, your model's not going to learn quick enough. So it's actually a hyperparameter. You have to just pick different ones and hope it does good. But they actually have a LR finder, and they basically train your model for a shorter amount of data, and they kind of see how it changes with different learning rates. And you just pick the one at the bottom, and that's your best one. So you can just train your model really quick that way. So that's just one example. And there's a lot of information in this notebook because they're kind of showing you a lot of technical stuff about, deep learning. But the code there to just train something is mostly there. And on the docs, they have like a much cleaner version to train something top to bottom. Let's look at a tabular example. See if this looks pretty good. Let's look at the data. So the data set, you always want to look at the data set first. All right, so they've got a data set and it's a CSV, because it's a tabular data, it's a table. You have sales ID, you have machine ID, sale price, sale date, and it looks like this. Yes, these are all the different columns, but I think they care about these ones the most. And I guess they're showing you how to use decision trees here. So So I'm not sure if you guys used pandas before, but you can kind of do some pandas arithmetic to kind of prepare your data in a nice format. And this is actually all you need to give to FastAI. So they have this big table, and then from this big table, I think they just take the fields that they care about, and then they hand this data frame, is what they call it, to a decision tree. And they just train it like this. So you make a decision tree here, and you can fit it with your data frame. So this is actually very similar to SciPy. If you guys use Scikit for like decision tree stuff. I haven't really used FastAI for tabular data, but they have support for it, which is kind of cool. NLP, I think this is going to be like one of the more hot ones for some applications that kind of saw here. But they go over text preprocessing, what is tokenization, how you do it with FastAI. So they're using IMDb. So this is a classic data set for text. And essentially what it is actually they should show examples so we can just look at some. Here. This is an example. This movie, which I just discovered at the video store, has apparently set, and I think they cut it off because it was too long. It's just a piece of text, and then the label is it's a positive review for the movie or it's a negative review for a movie. And it lets you set a callback for each label. Yeah, there's like a whole callback system in this framework too. But for just training something, once you get it in the data loader, it's just a matter of like passing it over to the learner object and then just running. But yeah, I guess they do let you set callbacks for each label. I need to check what that means in a little bit more detail though. So yeah, remember tokenizer, when you have a sentence, it gets converted to numbers. And one way to kind of do it, they're visualizing what happens when you kind of convert the text. So if you use a tokenizer, the sentence turns into a list of tokens. This movie, a comma, which I just discovered at the time, and so on. Even it's with apostrophe, you can see it got broken up to 2 separate tokens instead of having one, because you want to just have one. You don't want to have like a single row that represents that one word. You want to break it down as much as you can. So that's what they're doing here. It makes the dictionary smaller for mapping the words to IDs. So here, these are tokens that kind of show the start of a sentence and the end and stuff. There's some metadata here. They do this behind the scenes kind of for you. The library they use for this is Spacey. This is a classic NLP library for processing your data into tokens. They have models too, but a lot of people just use it for tokenizing, convert your text into tokens, because that's a really big thing to do. And let's look here. So they have something called subword tokenization, which is cool because they break the word down not just by word level, but into stems and subwords. So like the word apparently actually got broken into A, P, pair, ent, ly. And the reason for this is because some words are really long that you only probably would see it like once or twice in a couple of, in this case, movie reviews. And it's not worth having to learn that one word by itself and you only see it 2 times. So what they do is they kind of break all the words down, because some words actually have a lot of overlap on the subwords that they are used to build the whole word. For example, maybe not in the exact sentence we have here, but discovered and distributor are 2 different words. And you can see that they both have dis in it. So they can reuse the same embedding or meaning for that one subword instead of having to learn 2 different entire words. So lots of more reusability, which is kind of nice. It helps deal with words never seen before or rarely. And yep, so they're able to kind of get their text, turn it into tokens, make it into an array, put it into a CSV, and then print it just to kind of show what it looks like. And then they're able to train a text classifier So if anyone here is trying to do like toxicity classification or sentiment classification, again, with the data block, they have from a folder, and that's all you need. You just give it the folder of your text data, and it'll split it for you automatically. The get items here can be changed a little bit, and they have examples for that. I can also show some later in like mentor sessions to help you personalize this towards your own data, or at least point you to some better resources. And then to train it, you just create a language model learner. So before it was a CNN learner, that stands for convolutional neural network learner. Since we're doing text, this is called a language model learner. And you hand in the data loaders for your language model. This is the model they're going to use as the LSTM. And they're measuring accuracy and perplexity. These are good metrics. And they're doing 16-bit precision, so they don't use as much space on GPU. And then drop mult some. Well, I can't do shift tag because I didn't run the cells, but if you weren't sure what that is, we can always type in question mark, and just read what this actually does here. Or just shift tab is probably a little bit better. They train it for just one pass over the data. And it takes a while to train. It took them 11 minutes since there's a lot, since it's an LSTM. Remember, LSTMs have to look at one word at a time. It's not a transformer. And it is on a GPU too, I think. So they save the one epic, and they just show you that you can learn it whenever you want, or reload it. And then they train for 10 more. And you can kind of see the accuracy kind of floating around 30. And they also have some stuff on text generation and whatnot. So there's some work out there that use pre-trained models. I need to check if that's what they're doing here. But yeah, there's a lot of stuff on FastAI. These notebooks are a little bit technical. If you're just trying to get something up and running, it is a lot of information. The ones on their documentation, if you go to like learner objects, they have tutorials here. So, this is probably something I probably should have showed you guys at the start rather than the more complicated stuff. But if we click on text tutorial, they say how to use a high-level API. Right, and they kind of show the data here. This is the positive class, this is the text, positive class text. And then, you want to create a text classifier learner, pass in your data, you want to use the LSTM, and then train. You can see it's doing really, really well. And if you want to do a vision tutorial, they show you how to kind of get your data. They give it to the learner, and this is showing you how to predict a single file if you want to do that. Because after you're done training, your end goal is to take an image, give it to the model, and get an output. So this is showing you, okay, I'm done training. I have a file here. This is a list of files. So they're asking for the first one, and they pass it to the learner, and they're saying, what is this? It's tensor image. They give you these two here. And the way this works is there's two classes, 0 or 1, and you take the maximum. So this is the maximum. So it's saying class 0, and the label for class 0 is false. So I believe what they're doing here is to say if something is a cat or a dog. So false is probably for cat, for example. So all you would do is you would do this, and then the first thing you see here is the category you would predict. So this is their label, is false. It's not Boolean, like data in Python. It's not just a bool, it's actually the string false, because that's the class they chose. And yeah, they have it for classifying breeds too. This is the one they kind of included, but it's a lot more to the point and just shows you the minimal things you need to just run something like this. DLs, you can show batch to visualize it. And then giving it the CNN learner, and then find your learning rate. So here they chose 3 eneg3, which is kind of like in the middle, kind of on the slope, and just train, and then you're done. And then you can always do the dot predict for any image and just get the breed out. Same idea for classification for text or tabular. Only thing I didn't touch on is collaborative filtering. This is recommender systems. And then there's also reinforcement learning, but I don't really do too much of that. So I'll stop here. Kind of a lot of information. Takeaways is probably collab and gradient space as tools to use. And then FastAI is a great spot to learn how to do deep learning, and it's really quick and easy to get something up and running for a project or even like Kaggle competitions and stuff. So, yep, that is what I have. Yeah, sorry if it was a lot of talking and not much showing. I don't like rambling for too long, but yeah, this time I kind of just want to give you resources because I'm sure you guys are all capable of kind of making your own, research to kind of figure out how to do things. My star projector turned off. Got to turn that back on. So, yep. Yeah. If there's any questions, just ping me on the Discord because I'm gonna be awake for a while and I can help with anything. That's why I'm here. Mentors, judges, sponsors, you name it. So thank you, Manjot, for letting me do the workshop again. And where can you find awesome data sets to work on, Tenmei? Kaggle.com for everything and anything. If it's specifically for NLP, Hugging Face. Those two things. So, yep. That's all I have to show. Yeah, sorry if that wasn't much of a demo kind of thing, but that can come after when, if you reach out, I can help you get something running or something. So yeah, more of an info.
Oh yeah, there's an hour gap.
There's an hour gap. What is what?
Sorry, unmuted myself at the wrong place.
Oh, okay. No, you're good. I thought you were saying like there's an hour between this and the next session or something.
Yes,
yeah.
So if you haven't gotten the chance to have a break yet, you can now take an hour break until our next event.
Yep. If anyone needs to talk about anything, just DM or ping me. We can go to the mentor VC. So, all right, guys, I'm gonna hop out and go back to being awake. So, yeah, see ya.